Since Eric has a lot of relationships with people using IQ stations, we thought we'd kind of put these two talks together, and I'll talk a little bit about the IQ station project. This will be, not very long, and then we'll take our break. And then afterwards, I'll do the talk that we skipped yesterday afternoon on CalVR, and then we'll kind of have a little just closing chat with a couple of slides, and then it'll probably be about time to send you on your way, but you're not obliged to leave. The AVL people will still be here, and we'll be able to run demos during the break. We can run some demos over on the IQ station, and I don't know if we've probably been saturated with all the other demos in 4.14, but I have Tort running on the IQ station that we can look at, and you can see how it works with the touch. Yes. Oh yeah, so Dave needs a ride to the airport later this afternoon. Or a shared taxi if anybody has a. So what time's your flight, Dave? Yeah, he's not going to be able to ride on whatever you paid for the shuttle, right? The shared ride shuttle. But if they're already coming to the hotel and stuff. Yeah, right after this we'll break, and this will be more of a short talk. All right, so we've mentioned this, the IQ Station project a few times during the past couple days, and Eric talked a lot about some of his collaborators throughout the state of Idaho and neighboring states. So I just want to give a little brief overview of it, nothing earth-shattering, but it's basically kind of has its roots in the release of the responsive workbench at Fraunhofer in Germany in 1995, which was kind of this, it was more of a flat tabletop or kind of an architectural drafting board style display, but it was one screen stereo, kind of meant for one person, maybe a couple people over their shoulder to interact with things. That was followed up the next year by the Immersive desk, which I don't have a picture of, but it's kind of similar to this VizBox here. Also kind of drafting mode style, and the Immersive desk was by the same people that did the Cave, and so the software library that ran the Cave also worked in the Immersive desk. People were able to share their applications. They were able, a lot of times people would get an Immersive desk, or what we did at DRI is we got our VizBox prior to getting our Cave so that the staff and students could kind of get up to speed on a lower cost, lower footprint display, and also these smaller kind of displays travel a little bit easier, and you can take them around to state fairs and things like that. So then in 2008, kind of at the same time at the Desert Research Institute, we were coming up with this ability or desire to have these low-cost displays. We needed to put something on our other campus. So the Desert Research Institute has two main campuses, one in Reno, which is where we had our Cave, and one in Las Vegas. And we wanted our researchers in Las Vegas to have the ability to do some development work at least, and maybe even just useful work locally in that campus. So that's kind of when this initiative started, and then just last year, Jeff's been putting together the reference build that we have over in 4.14, and we'll look at that in a little bit. Oh, and we'll talk a little bit too about we have a web page and stuff that goes with it. There we go. So the catalyst specifically for the IQ station is really the advent of the consumer off-the-shelf 3D TVs, where you could just buy a TV and it was stereo ready. There was also, kind of an important event was this company called Natural Point released their kind of low-cost mocap camera system, and we found they would sell you as few as 3 of these cameras, which cost about $500 each. We found that you really kind of need about 6 to get to get some relative tracking, but even at that, you're talking about $5,000 with the 6 cameras plus a little bit of extra peripherals to go with it. And now you're really kind of talking about sub $10,000 to put together a virtual reality facility that's that's not, you know, a $500 head-mounted display and Wiimote tracking, right? So, and then of course we already had the graphics cards. We'd had them for, you know, a decade or so. So the initial period, was a lot of this kind of stuff where we had these big TVs and cameras mounted around them and frustrated trade show preparations. This is Oliver Krylos, by the way. We mentioned his name several times, but I don't know if we have a picture of him. That's Oliver there. Yeah, that's right. And so this was an event we were doing, well, I can't remember. I think maybe at the International Symposium on Visual Computing. Or no, actually that was IEEE VR 2000, IEEE Viz in 2008 over in Columbus, Ohio. And all right, so anyway, so commercial off the shelf, it's inexpensive. That doesn't necessarily mean it's not going to cost you some staff time. It's not necessarily easy. Right, so I found several times that I knew way more about the technology than the people on the customer support side. And so if I run into a small snag, it would be something that if I were talking to, you know, SGI or Christie or something, they just have an answer right away. But now if you're calling Samsung or going to Best Buy to get an answer for a TV you bought, you know, you weren't going to get an answer. I literally went to Best Buy and the guy told me the TV I bought, which I already knew did stereo and had shown it did stereo, told me it didn't do stereo. They didn't sell stereo TVs. And I have another story where I went in a circle with the vendors support phone staff, which I won't tell you. And the other problem, of course, with commercial off the shelf is that they're always refreshing, right? Every year they come out with a new model, if not more than once a year. And so if you want to have several systems that are basically the same, you have to buy them all at once. You know, sometimes the changes from year to year are minimal, and so you're not hurt too much. You don't know that that's going to be the case. And sometimes they make big changes. We were talking last night at dinner how, you know, Samsung, in their first TVs, we could just use our crystallized glasses, our crystallized emitters. They had a 3-pin mini DIN plug right on there, you know, totally fit with the professional active stereo systems. And now, of course, then they decided they wanted to go their own way and kind of broke that mold. And then, you know, there's a lot of trial and error. You know, how are you going to get the stereo from the PC to the TV? With the Samsung, it turned out to be pretty good, at least initially. We had a lot of problems with the fact that we were using IR tracking and the glasses used IR communication. We talked about that a little bit last night too. And eventually the Natural Point company was hearing from enough people, and they're a small enough company that they started responding. Even though they were kind of developed as a mocap company, they found that they were getting a lot of virtual reality related customers, and so they actually did respond to us and eventually put a fix in where they could synchronize with the stereo signal, and then it started working. But this was after about 2 years of trying to do crazy filters and stuff like that, and little shades where the tracking went this way and the stereo signal went this way. And so a lot of this was, Oliver was really independently developing this stuff. At the Desert Research Institute, we were also independently developing it, but we were still sharing ideas back and forth. And so having this community helped us discover and get things done a little bit better. So the components, you know, you need a 3D stereoscopic display. You need something to separate the stereo, so i.e. glasses, some tracking if you're going to have a virtual reality facility, a PC, and then something that sometimes you don't think about when you're budgeting these things. You need something to put this thing all together, some furniture to attach it together. And then maybe you want some extra controllers and maybe a touchscreen, which we have on our system. So I'll talk a little bit about the 3D TVs. They were introduced in 2007, which I say before was the catalyst sort of to that. Is my mic on? Did I go bad? Oh, there it's working. All right. So Samsung had these early models. They were DLPs. They used this new checkerboard stereo. So everybody's kind of now adapting their virtual reality libraries to handle this new style of doing stereo. They had a couple of different ways of emitting the light. And back then, you had to make sure you were getting the LED version. The Mitsubishi also had a series. I thought the Samsungs were better. Ironically, Samsung discontinued their DLP line before Mitsubishi did. Then Plasma came out, and now, of course, we have LEDs and high frame rates. But here's a 103-inch Plasma display that they had at a VR conference a couple of years ago. I mean, this thing is huge and expensive. Oops. You may have. I haven't been following it, but I mean, it wouldn't surprise me. Oh, Eric asked if Mitsubishi has just discontinued their DLP line of TVs. Do you know? Yeah. Chris would probably know, right? So modern ones, Sony has an active line now. We recently did, well, I guess a little more than a year ago, we did some side-by-sides, and we found that the Samsung active stereo had pretty bad ghosting, so we kind of wrote them off, especially if they're going to go proprietary with their glasses. And then we kind of looked at active versus passive stereo, and a couple brands that were doing passive, kind of focusing on passive stereo is LG and Vizio. LG being the slightly higher, I guess, name brand. And we decided to go with the passive, even though in theory you're guaranteed to lose half the resolution, whereas with the active you have the opportunity to have full HD resolution per eye, and with the passive you're only going to get half. But we just found that the ghosting was minimal with the passive. The glasses are cheaper. You don't have to worry about people having the glasses on and not knowing that the batteries are dead. And it just seemed to be really an all-around better solution. And then there's some other opportunities with low-cost projectors as well. Yeah. Oh, yes. Good point. Yeah. So we wanted to have a two-screen VR display, even though it's low-cost, but two low-cost displays. And yes, with active stereo, now you have to think about synchronization, whereas passive stereo, you don't. Although with passive stereo, you do have to think there's a window of I don't know what yes, a sweet spot. Excellent. Yes, there's a window where the sweet spot is just right for the left and right eyes to hit you just right, and it tends to be, I think, from just above center to down. They assume you're going to have your TVs above you, and so there's a sweet spot. And when kind of as an aside, when the Electronic Visualization Lab in Chicago built their Cave 2 using the same technology, they had some up high and some down low. And so if you have the ones that are lower, as they normally come off the shelf, you have to be like on the floor to get the right stereo. So they worked with the manufacturer, and they were able to, I think anyone can do this now, but you can actually buy it so that the sweet spot is whatever angle you want. And it adds about 50% to the cost if you get the non-commercial sweet spot. So tracking is the other big thing. If we're going to call this virtual reality, we need to have some tracking. I already talked a little about this. About a little over $5,000 for a set of 6 cameras and the extra gear that lets you synchronize it with the stereo IR stereo emitters. New lenses are coming out from OptiTrack. I don't know if I have AR track. Oh, I do talk about it a little bit later. All right, this was actually some of our initial setups where we were using the OptiTrack system. We've actually kind of graduated a little bit from this, although I think most of your collaborators are using the 6.
Yeah, we have 3 that are bars, 3 track bars.
Right. Right, so that's kind of a semi-new thing that's coming out of a picture of that in a little bit. So this is kind of where we were a year or so ago. One of the, for me, downsides for the Natural Point software is that it's Windows-only computing, so if you happen to be running a Linux PC, or if you wanted to be able to dual boot, you still had to have at least one machine on the side that did Microsoft Windows, or run it in a virtual machine. We were going with these Mac Mini, or A-Open computers. And then, of course, now you need another display for that, or you need to switch it into your main display, so it kind of complicates things a little bit. And that's been solved a little bit with one of the slightly higher expensive solutions. Of course, if you want to drive it, the computer you're going to drive it with can be, pretty much anywhere in that range. If you go above 10,000, you're probably really getting crazy. And then you want some controllers, all of which are relatively inexpensive. Even the Razer Hydra, which is a true, tracked 6 degree of freedom tracked device, is only $100 for a pair of controllers. All right, so our first prototype from a couple of years ago is here's pictured here. We had this big furniture table which we could raise it up and down so it could kind of accommodate people of different heights. And we didn't have the sweet spot issue with that because it was active stereo. All right, and then we kind of started thinking we want to add on. Eric had this, I think, really good idea of having a lower screen that was a touch screen. And one of the things we didn't know how well it was going to work was, at the time, you could just, you could buy these touch screens where the touch screen was integrated, but it was not integrated onto a stereo-capable display. So we did a couple things to merge it. Here we're running ParaView, and so this works pretty naturally. The ParaView screen here on the touch screen is really just the client, the desktop interface, so you don't need the stereo. And then up here with the head tracking, you get the stereo and a little bit larger display, and it works really well. And you can press the buttons on ParaView. You can rotate the object using the touch screen. Now, ParaView has a slight quirk in that at the moment, it renders the same kind of stereo to both. So if you turn stereo on, you actually get dual images rendered to this screen, but you can't see it in stereo. But that's something that we're putting pressure on Kitware to take care of. And kind of our new design then that Jeff's been working on is that we're just putting a PQ Labs overlay on top of the stereo screen, and we did some tests initially to find out whether the glass for the PQ Labs would interfere with the passive stereo, and it doesn't. So so that's the system we have set up over in our lab space. I went backwards. All right, so tracker calibration. This is something that we're now kind of moving away from. One of the things we had to do is, where are you going to put the cameras? We kind of wanted it all attached together. One of the things Oliver at UC Davis did is he put his cameras actually up on the ceiling for some of these things, but that doesn't really make it a portable system. Now it's kind of an installation. So we try to figure out ways of putting the cameras. Idaho National Lab really has a nice way where they put PVC tubes and it's fixed to the table. And Eric showed a picture of that earlier, and I think that works pretty well. So kind of as things progress, the next kind of phases that we've been moving into is instead of having individual cameras, we have the both natural point and AR tracking cell with these camera bars. And I have a picture of that coming up here. There we go. So this is from natural point. It's basically 3 of the cameras that we saw before. And even though, so I said before though, when we tried 3 camera systems, it was not optimal, right? So we're kind of going back to that if you get this. This has a really big win in that you don't have to calibrate. The software knows exactly where the cameras are. It knows exactly how they're oriented and the distance between them. So one of kind of the big pains of having the cameras is that they can be anywhere. If they get bumped, you have to recalibrate them. With the bars, that's not going to happen. Other than you might have to, if it gets bumped, you might have to do the overall thing, but you have to do a little tweak. Yeah, Dave. Right. So Natural Point sells 2 of these. They sell a 2-camera version and a 3-camera version. The 3-camera version is $2,500, and I would at least get the 3-camera version. Now, we're recommending, if you can afford it, to actually take one step better and getting the AR track version of this, called the Smart Track, and but that educational pricing on that is about $8,000. So you're adding, $5,000 to it. But their cameras have a little bit wider range. I think they must have better resolution. At least their software does a better job. It has a better working volume than this. You don't need the PC. Yes, right. It has a built-in PC. So if you want to go Windows or Linux, you don't need a second PC. This thing has it all built in, and they have software for both Linux and Windows that communicates directly to it, the D-Track software, and we can see that over in the other room there. So you do get what you pay for. It costs more, but you get I think you get what you pay for. All right, so we're coming to the end of the talk here. So one of the goals of having these stations, the low-cost VR, is that means it makes VR more accessible to a lot of people. but there's still, like I mentioned at the beginning, kind of this knowledge gap. You're trading cost for maybe frustration and the need for more knowledge. And so one of the things we wanted to do is kind of build up a community. And we had started this a little bit with that session that we had at the IEEE Viz conference in 2008. And so we created a web page. We call these things the IQ station. I guess I didn't say what that meant at the beginning, right? So that means I quadded, so 4 I's, or quinted if you want to count the other one. So we have interactive, immersive, inexpensive. The 5th one was Indiana and or Idaho, but I can't remember what the 4th one was now. Interface, there you go, excellent. It says that actually. It probably says it right here somewhere actually. Right. And we collaborated, we did some papers on this to kind of spread that. That's right, that's right. Iowa and Illinois can join us if they want as well. So we have this web page. This kind of goes to a front end page which just has a couple of introductory paragraphs. Sort of the bulk of it is the wiki, which you can get to from the front of the page. And I'll talk a little bit more about the wiki actually on the closing talk, but to pre-repeat myself, anybody can read it, so it's open to the public, so it's shared information. We want people to be able to do this, but you do have to have a login if you want to write to the wiki, because we don't want to get spammed. But we'll give that login to basically anybody we know who's doing, can contribute, so that's not a problem. Oh yeah. Some of you have seen that video. So, of course, there's now some other possibilities. There's low-cost tracking that the Connect provides. And also, there's a technique that Oliver does where he captures the point cloud for this, and he actually puts collaborators into the virtual world just from their point clouds, which is pretty cool. And I have this kind of video that talks about the next step of glasses-free active stereo, which this is just a picture of it. Have you seen the video? Yeah. I know, yeah, we shared it around, yeah, so. Probably half of you have already seen it too. This is just a picture of it, so if we want to, we'll have to go to YouTube if we actually want to watch it. And I have the YouTube code if we want to see it here, because I have it on my laptop. Let's see. Because I don't know the words you'd use to search for it. "3D without glasses," Chauncey says. All right, actually, I just typed this in. I have the actual little YouTube code. Have you seen it before? All right. Oh, we're already at YouTube, so let's see. All right. What is it? V equals? UEF17Z. Normally I just play it from my laptop, but I forgot I was going to be connected up. CB8. Is that right? Is that how you do that, Jeff? Yeah, I think you have to do a question mark before the V, right? Question mark. No, that didn't work. The watch, question mark, V equals, yes. There we go. Do we have sound? It's still an advertisement. So there we go. I don't. There we go.
Hello, so my name is François Ogel. I'm going to talk to you about a very new device that creates 3D without glass. So every
What did I do with the thing?
What do I sign up?
Yeah. All right. There it is. So that's it for the IQ Station talk. We'll take a break now. What time is it? I guess we'll just take maybe a 20-minute break. We'll reconvene at 11:30. And then I'll do a short talk on